Hey there, welcome to the Daily Space Weather. We've got coronal mass ejections, proton events, radio blackouts, and massive amounts of solar flaring. So a huge uptick here in solar activity continues. We'll be covering it in depth here at the Smash News Network. Least busted name in news. There you can see some coronal mass ejections happening. Will they be directed toward the Earth? Well, we'll have to let you know a little bit later in the video. Here's yesterday and today's data from SDO. And multiple large solar flares. We'll cover that in depth as well. Sunspots have been mostly stable here over the past 24 hours. A little bit of growth in this southern one, right in the earthly portion of the solar disk. You can see how far south those sunspots indeed are, indicating that we've got a long way to go through solar cycle 25. Got about 6 named sunspot groups once again today. This is your SDO magnetogram, I think. There's your SDO magnetogram. And the flares have come from these sunspot groups here in the southwest and this one over here in the southeast. Dueling sunspots. Brief look at volcanoes showing Shiveluch erupting 12,000-foot ash plume as Shiveluch explodes. 6,000-foot ash plume from Subanose Jima. Semeru exploding. 14,000-foot ash plume, flight level 140 from Semeru. New one on the list here, Awu. Recent observations showed no significant signs of elevated activity at the volcano leading to eruption anymore. What do we have here? One of Indonesia's deadliest volcanoes. Powerful explosive eruptions in 1711, 1812, 1856, 1892, and 1966 produced devastating pyroclastic flows in lahars that caused more than 8,000 cumulative fatalities. Anyway, it looks like it has chilled out here. Low seismic activity at Awu. Fuego in Guatemala exploding, flight level 150, 15,000-foot ash plume. In Colombia, Nevado de Ruiz, 24,000-foot ash plume as it explodes. Sangay and Revenador producing explosive activity there in Ecuador. 23,000-foot ash plume from Sangay, 14,000-foot ash plume from Ecuador, and a 22,000-foot ash plume coming out of Sabancaya in Peru as it explodes. Please don't pole vault the caldera. Seismic activity here pretty low over the past over the past 48 hours. Here's the last 24, and we do have some quakes there in North America. They're of relatively small magnitude. One actually happening in Colorado. And I think the largest quake of the past 24 is this 5.0 at Vanuatu. That one was at extreme depth there, 172.8 kilometers estimated depth for that 5.0 magnitude. That came in at 1610 yesterday, Universal Time on August 26th. So really a low number of quakes and only small quakes. And let's get back to space, since there's quite a lot going on. Protons showing up in Earth's field-aligned currents, causing some radio blackouts. We'll get to that. That's the last 24 hours in 94 and 171 angstroms from SDO. Let's subtract 94 and just include the house favorite, 171 angstroms. And let's take a look at Earth's geospace first. The 10.7 centimeter radio flux. It's only come up one solar flux unit to 119. There's the 1 year graph. It's this black line. The 10.7 centimeter radio flux is proportional to sunspot number. In other words, when sunspot number goes up, so does radio flux. We've also seen an increase in the solar wind density here. So there is a coronal hole high-speed stream density wave arriving. NOAA forecasting some geomagnetic unrest early in the morning on Monday, August 29th. And let's continue on to look at the earthly geospace. So this is the last 4 hours of Earth's magnetic moment from space. And when we talk about field-aligned currents, this is viewing the Earth from the side, essentially, the meridional plane view. And the field-aligned currents are going to be in this area right here at the poles. And those are where the protons show up when we do have proton events. And when they're decelerated by the molecules in the atmosphere, they emit radiation, and that's what causes those deabsorption region blackouts. Field-aligned currents, so those particles traveling at a significant percentage of light speed. Again, we'll get to that. That's the last 4 hours of Earth's magnetic moment from space, our Geospace Magnetosphere movie. Next, Earth's magnetic moment from the ground. Things geomagnetically calm here at the moment. Many are forecasting that there will be some upticks here. Anyway, we are expecting that coronal hole high-speed stream for sure. I think it's going to show up a little bit earlier, maybe late in the day tomorrow, but NOAA should be close with its forecast. So there you go, KP index only at 2. The planetary K index, a measurement of global geomagnetism. And let's look at the real-time solar wind to see an elevated solar wind density here. We've just seen it drop off, so it made it up to 33 protons per cubic centimeter there. And now we've seen it drop back down. And a characteristic of coronal hole high-speed streams here, we see the solar wind speed coming up. We see the BZ, this top pane up here, this red line going into negative territory here. If that stays down there in negative territory, we may see geomagnetic unrest or geomagnetic storm conditions just from the magnetic field orientation. So that's the vertical component of the magnetic field. When the BZ goes negative like that, it is more prone to induce large currents in the Earth geospace. So if that stays negative, we could see geomagnetic unrest or geomagnetic storm conditions today. So current conditions are about 18 protons per cubic centimeter for the solar wind density. Expect that to drop a little further. And solar wind speed 371 kilometers per second. Expect that to go up a lot in the coming 12 hours. GOES magnetometer showing a sudden dip there, measured by the GOES 17. That is a geosynchronous near equatorial orbiting satellite. You can see they had to make some maneuvers here with their thrusters to stay in their locations. The N's and M's stand for noon and midnight local time for the satellite. Let's take a brief look at the top view ecliptic plane field plot showing the heliospheric current sheet and its polarity. There is a North Pole current sheet headed this way. We may see that arrive as early as midday tomorrow. Keep in mind, folks, the magnetic environment can change with essentially no warning. Here's our line of sight field plot showing the sun's B field in blue. As the solar polar fields migrate throughout the process of solar cycle 25. Remember, folks, it's not just sunspots, it's also the migration of the solar polar fields. We can see some North Pole-oriented coronal holes rotating in here on the east. Huge, very well-defined South Pole-oriented coronal hole right in the earthly zone here. And there's a sunspot in the middle of it, something that we've never covered before on the channel. So here's some imagery of that. This is 211 angstroms, actually. You can see this very well-defined South Pole-oriented coronal hole there in the south-central heliographic latitudes. Just some spectacular imagery there from the SDO for your viewing pleasure. Next, we'll get to sunspots here at the Smash News Network, least busted name in news. Thanks for leaving a comment, Acrylic D. Likelihood of major solar flares remains very high. In fact, it's actually going up since sunspot 3088 is approaching the limb. Don't be surprised to see an X-class flare from that sunspot. It has certainly proved that it's capable of producing major flares. So we've got about 6 named sunspot groups at the moment. Again, they've been mostly stable. We've seen some growth of sunspot 3086. The main producers of flares are 3088 and 3089. This group up here, 3090, has evaporated entirely, I think. It doesn't change the fact that the likelihood of major flares, including X-class flares, is very, very high. Here's some imagery in the SDO continuum. And we'll get a little closer. Again, all the sunspots except that one in the northwest are in the southern hemisphere. We've zoomed in on the equator there to include all the sunspots. We'll also show the SDO magnetogram. And keep an eye on sunspot 3088. Remember, folks, large flares are more likely as a sunspot sets or rises on the limb. We're going to get to relativistic particles first. If you want to relate to the channel, head to Twitter. We've got over 14,000 tweets, and we've recently gotten above 300 followers there. If you don't have a Twitter account, make one. You'll see shares you won't see anyplace else. We don't have time to just share everything on the Smash Team page, although we do send out email alerts like we did this morning. Since there was a Proton event, we sent out an email push. So if you want email alerts for all kinds of things, from tsunamis to Proton events to other breaking news stories, head to smashamash.com/smashteam. Sign up. There is a bronze level, which is of zero cost to you. There's also a silver level, that's $2.99 a month. Gold level, $9.99 a month. There's also a gold annual paid-up subscription level, which is the best value. It includes complimentary merch. Yes, complimentary merch. Thanks to everybody who supports the channel via the Smash Team membership services. Smashamash.com/smashteam is what we've replaced Patreon with, although we still are on Patreon as well. Today's featured product is the Galactic Federation Special Forces, because we're not only interested in making Earth not suck again, we're also interested in making the galaxy not suck again. So, Milky Way Galaxy team for the win. As I say to you, Universum Liberate. It's the motto of the Galactic Federation Special Forces. So pick up some merch. The symbolism on the Galactic Federation Special Forces shield represents the Milky Way Galaxy. The key represents signal strength, integrity, and security. The lightning bolt represents galactic scale instantaneous reach. And that little bright spot in the upper right is classified. So, number one, I order you to pick up some merch, such as the Galactic Federation Special Forces. Engage. You'll find a link below the video and on the homepage that'll send you to the Redbubble shop, where products are listed in order of best selling. If you want to improve your own health, join the SureMed Association, the American Better Health Association. SureMed, it'll give you all kinds of discounts and all kinds of ways to improve your health. Things like doctors by phone, the teledoc service, because who wants to go to a physical doctor? What do you think, it's 2019 and you're going to actually go out and go to a physical doctor? Who's going to do that? Teledoc doctors will call in your prescription for you, so you never have to go to a physical doctor. There's even a virtual veterinarian service, which is similar. You can also add accident and critical illness insurance by picking up the Plus or the Premier level of SureMed membership. Links on the homepage and below the video to that as well. Welcome to the Neo-Renaissance. Congratulations on realizing this channel exists. We cite fact after fact. We show the most detailed imagery of the sun and put up the most comprehensive space weather content in the world. So thanks everybody who tunes in. Get involved, click our links. Thanks to everybody who has. And if you're unwilling to do any of that, just press like, press subscribe on YouTube, press the share button, leave us a comment. Even if it's a derogatory one, we still appreciate it, because you're not going to hurt our feelings. I've been an admin on websites since before there was such a thing as social media, and when we say in the Smashes of Hazard theme song that I've been getting in trouble on social media since before its existence, it's all too true. Not an internet noob. I've been on game servers before even MySpace existed. Thanks again to our YouTube subscribers for putting up with the pathetic censorship on the platform. Next, the GOES X-ray flux, and this last M-class flare sent relativistic particles traveling at a significant percentage of light speed toward planet Earth. Two major M-class flares, including this M7.2 and this M4.8, and a flare happening as we stream the video. We should have some great imagery on the GOES 16 SUVI. Let's take a look at the flares that have happened in the last 24 hours. There's 94 angstroms, and why not get a little closer since they're all out of the southern hemisphere? Spectacular imagery. How you like them apples? "94 angstroms and 171 angstroms are the best wavelengths to view solar flares from the SDO because they take 10 images per minute instead of only 2 images per minute. Here's 131 angstroms. So here is the GOES proton flux, and you can see this is now subsiding along with the polar radio blackouts probably subsiding as well, but we did see a significant proton event there. Not getting into warning thresholds, but nonetheless causing some polar radio blackouts. Why? Well, because when those protons show up, they end up in Earth's field-aligned currents. So you see those orange lines there. That is where protons tend to go. And then when they get low enough in the atmosphere, they are slowed down by crashing into things, and they emit radiation, which does indeed modulate the D layer of the ionosphere, causing radio signals to go flying out into space instead of being refracted back down to the surface. So that's what's going on with that. And here is the deabsorption region animation. So this last large flare that's the M-class flare right there, and that causes a radio blackout as soon as the X-rays arrive. Right there, it was over the West Pacific, and then just a little while later you see, boom, protons showing up at the D level of the ionosphere. So that's your polar radio blackout, mostly at the North Pole. It is summertime yet in the Northern Hemisphere, and that'll probably subside there in the last half an hour or so. You can see that there subsiding as those proton levels drop. Next, we've brought up a star chart. We like folks to be oriented, and we encourage you to look up and understand facts about science. Facts like the sun and the planets are not going to kill you. Here's your solar system forecast. Happy new moon, by the way. Let's advance this 1 week. As where things will be in a week, we will have a crescent waxing on September 3rd. Next, some coronagraph imagery. And I think one of those is a partial halo. I think the first CME there may contain some earthly directed, maybe a glancing blow. I believe NOAA is not forecasting that to strike Earth, but to strike Stereo B instead. We'll just have to wait and see. It's not going to be a direct impact. Most of that ejecta headed off to the west. Fortunately, the Stereo A data is back also. We're going to show you that here in a minute. First, the detailed imagery here from George Mason University. That is yesterday's coronagraph imagery. And here's today's imagery so far. So another CME there happening right at the end of the video. We'll have to see where that's headed, but I would suspect that it's probably off to the west as well. So we've paused the Stereo A imagery. Stereo A is located, by the way, at Lagrangian point 5. The SOHO-LASCO C3 located at Lagrangian point 1. So from Stereo A's perspective, Earth would be off on this sort of a line. From the SOHO-LASCO C3, Earth would be behind the coronagraph disk. And we've paused this here at 1623 because this is this huge CME. And if you look at the Soho-Lasco C3, it looks like most of that ejecta is indeed on the west, but there is a partial halo. You can see some ejecta there above the disk. None really on the east side of the disk over here, so could be a glancing blow, could be a complete miss. I would tend to err on the side of caution and say it's a glancing blow, but we'll just have to wait about 3 days and see what happens. So there's one, and here's a second CME. That one, I believe, is a complete miss. And there is some missing data there on the Soho-Lasco C3. It looks like some relativistic particles there striking the aperture. A little bit of a smear there on the screen. And we'll let those play through. And we ain't done yet. We've got some filaments, especially in the northern hemisphere there, some in the southeast as well. So the likelihood of additional coronal mass ejections continues to be quite high. That is the ground-based hydrogen alpha imagery from El Teide, Spain. Next, the GOES 16 SUVI. And again, we saw a flare happening while we streamed. It appears to have come from sunspot 3088. I think probably only a C-class flare there. And by the way, we streamed 24 hours yesterday on Twitch, so we captured all of those events. I'm sure some spectacular imagery. So if you want to see a full day's imagery of the closest star, we've got 24 hours. And the GOES 16 SUVI is great because it shows a wide field of view, and it's good at showing coronal mass ejections. Twitch.tv/SmashoMash is where we regularly stream live. So here's the last 24 hours in SDO 304 angstroms ionized helium. And let us know in the comments what's in your coffee. My coffee today is Peruvian medium roast organic ground. And it does indeed have cocoa powder and cayenne pepper mixed in. And let's get into our bonus feature segment, where we look at things like the electron flux and the ionosphere and satellite charging hazards, which there are none of at the moment. Things are clear sailing for satellites at the moment. We see a dip here in the electron flux, as we do regularly when we see the arrival of coronal hole high-speed stream components. We are waiting for the high-speed portion. We've only seen the density increase at the moment. So there's a dip in the electron flux following a lengthy high level of electron flux. There's the NOAA forecast, and we can expect to see this a little bit lower today, maybe a little bit lower than the forecast, but the forecast there somewhat accurate, I would say. There's the 1-year chart of the greater than 2 mega electron volt electron fluence. Before I continue on, allow me to pause for station identification. Welcome to the Smash News Network, least busted name in news, where we cite facts. And we don't cite any propaganda, nonsense, fraud, or ridiculous crap about things like space weather. Here's a diagram of the atmosphere. It shows you things like the penetration of electromagnetic radiation, temperatures of the thermosphere, and molecular composition and density. Why? Because we're showing you the F ionosphere layer next. Here's the vibrational frequency. going on at the F layer of the ionosphere. So we talked about the D layer earlier. That is the lower layer. Again, feel free to pause the video on this frame here. The D layer is down there, the top of the mesosphere. This is a higher layer, the F layer. And in many ways it can be considered the bridge between Earth and space. Space, a frontier. These are the voyages of facts. So we're going to let that play through, and then we're going to show the anomalygram. So here's the anomalygram, anomaly in megahertz from the 30-day median. And we'll pause it on the latest image. There's 11:45 Universal Time, coming at you a little bit later than normal today. And there's 11:45 Universal Time anomalygram. Next, the total electron content forecast. And we may see this get a little bit jiggy here in the coming days. We regularly see some anomalies in the total electron content forecast. The location of free electrons often shifts a bit as coronal hole high-speed streams arrive. You do see some electron bleed there toward the poles, and that is normal when a coronal hole high-speed stream arrives. We are seeing the transition from the high-density portion to the high-speed portion at the moment, so you'll see those electrons getting a little bit out of place. That is what we expect. That's normal physics. The total electron content forecast shows you the most likely places for GPS errors, and you'll see more of those farther from the equator at the moment. This imagery just shows distances to things in miles. Feel free to pause the frame on this video. Feel free to pause the video on this frame if you like. Now it's time for the latest intensitygram and latest colorized magnetogram. This sunspot down here, quite likely to produce an X-class flare. As it sets on the limb, stay tuned for more exciting activity from it. And don't be surprised to see some exciting activity from sunspot 3089, because it has produced M-class flares already as well, and it remains beta-gamma class. It's a classy sunspot. Activity dipping in the northern hemisphere, although there is some new activity rising in the northeast. So let's see what we can see as far as that. We'll bring up this triple composite image from SDO. That is 211, 304, and 171 angstroms, 2 species of ionized iron and 1 of ionized helium. And there is some activity up here. Looks like it is a sunspot because I see quite a lot of filamentary motion up there. Pretty sure that is a sunspot. And it's at a quite high latitude there, as you can see. Already seeing a little bit of likely X-ray output from that region. You can see some plasma splashing around up there on the surface. And let's get out of space and head to Earth for our brief meteorology segment. We're going to blast through some meteorological data here. I discovered that forecasting the weather was too easy over a decade ago as a function of being a pro cyclist. And hey, here you go. Here is some meteorological bonus features for you. The largest waves of the Earth are located around the Southern Ocean. So there are some 28 footers there in the Southern Ocean. There's nobody to enjoy them, although there are some 28 footers here off the coast of Australia as well. So there may be some great surf down there. I don't know if there's anybody there or not. I'm not an expert on Australian geography by any stretch. So in any case, let's break out the standard wind maps that we look at regularly. here at the Smash News Network, least busted name in news. And by the way, thanks for tuning in. And congratulations on realizing that the channel exists. So, here are the surface winds. Oh, wait, there we go. There are the surface winds of the eastern world. And there is indeed an offshore wind at southern Australia. That helps for surfing. It helps to stand waves up. Here are the jet streams of that side of the planet. Let's check out the west side. There are the jet streams of the Americas. Rather incoherent jet stream over the U.S. A convergence happening over eastern Canada. Doubled up jet streams over the southern hemisphere. Here are the surface winds of the west side. And here are the surface winds of the central world. Last but not least, there are the jet streams of the central world. Let us know in the comments if you've been following the Vuelta a España. One of only three-week stage races in the sport of cycling. Next, we've got your weather.gov map, and not so many weather alerts here, although some gale warnings around Alaska, Hawaii, and California. If your county's lit, click your county. Those tan areas are special weather statements. We can't cover them. We ain't got time. Again, if your county's lit, head to weather.gov and click your county. Some red flag warnings happening there in the northwest. Next, your total accumulated precipitation forecast based on the GFS model. Precipitation totals shown here in inches. Once again, that's your 72-hour total accumulated precipitation forecast. Some heavy rains, like 4 or 5 inches of rain forecasted for portions of Iowa and Minnesota there. Also some heavy rains striking Florida, especially the southern portion. Next, your windy.com pressure map. Strong low here in northern Canada. And a few anticyclones here. Some clockwise rotation happening there in the North Pacific. Constraining a low pressure system, but not helping to strengthen it. Next, we've got your NASA GOES lightning mapper. Heavy lightning there in Central America. Check it out. Severe lightning happening there. Yowzers. And let's take a look at a real-time lightning map, as we do have some active cells here just moving into Wisconsin. So east of St. Paul there's certainly some thunder rolling in. Looks like it's calming down a little bit since we did show prep. And let's zoom out to the global map. There you go, from lightningmaps.org. Next time you hear thunder, check it out. Maybe you can frighten the natives by forecasting thunder. Maybe you'll convince them that you're Odin or something. Wait, Thor? Odin's lightning, Thor's thunder. That's the son of the... Yeah, it's all an explanation of nature, folks. It's almost like science. And next we're headed to the AccuWeather.com animated radar map. Severe storms there. Let's briefly zoom out to show all 50 states. Come on then. There we go. Doppler radars, if you're wondering, they show vertical motion of water droplets in the air column, and the Great Lakes are seeing some severe storms there showing up. We'll focus on the lower 48 and check it out. That is some harsh weather there. It's going to be a nasty day for Lake Superior and Lake Michigan especially. Later on, Lake Huron. Those are some strong storms. Look at all the red. Those storms likely to produce strong winds, hail, possibly even tornadic activity. Let's hope not. And let's show the shortwave radiation satellite. Please. And those time out regularly, folks. It's because the video's kind of long today because there was a lot to cover. So here's your water vapor map. Here's your shortwave radiation map. 3.9 nanometer infrared radiation shows clouds and fog when it's too dark over half the country to use the visible satellite. There is the water vapor map. Yeah, we see clouds even when it's dark, folks, because we know which data to look at. Citing facts. It's what the channel's all about. Check it out and let's zoom in on this. This is like, that is one hell of a nasty set of storms there, folks. That is going to make for some severe, like huge waves on the Great Lakes. You know, the Great Lakes are actually, the Great Lakes Triangle is much more dangerous than the Bermuda Triangle. Did you know this? Yeah, the Great Lakes, they get narrower where they come together, and that magnifies wave heights. The Great Lakes are very dangerous indeed. Perhaps you've heard the Gordon Lightfoot song, Edmund Fitzgerald. Yowzers. So that's your recap. Here's your shortwave radiation map. It shows clouds and fog. Since water emits radiation, yes. Water, it's a greenhouse gas. Facts. And again, there is your water vapor map. That should help to clarify things, and these things are going to move in a pretty predictable fashion. Thanks for tuning into the Smash News Network, least busted name in news, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.